Good evening. Welcome everyone back to the second day of our Arduino for School students. And in the today's session, we are going to discuss about a new concept, that is digital read. Yesterday we discussed about digital write as well as delay. And today we will be discussing about digital read. And this is the circuit which we are about to explain today. This is the Arduino, and today my pattern of connection has also changed. See here, I have connected this ground to this rail. That is the rail with 30 pins or 30 points. As well as I have connected this positive to the positive rail, or there is whether it is positive rail or negative rail, it is defined by us. If we connect the positive or 5 volt to this becomes the positive rail. So I haven't changed any alterations. That is that is in matching to the notations or the notification on the board I have connected. So this will be easy for us to identify. So I have connected my 5 volt to this positive rail and the ground to this negative rail. And there is a little bit change in this connection. Yesterday we connected the negative directly to this cathode, but today we have connected it to the negative rail. See here, all these 30 points will have negative, that is ground, that is 0 volt. So I have connected this LED cathode to this ground via this point, and there is no change in this. There is the anode of the LED is connected to the pin number 12 through a resistor, the same resistor. There is no change in our circuit, and here we have inserted a switch, and this switch is known as push button switch. I will show you the hardware of the push button switch at the end of the webinar. I have it one in my kit, and if I remove that, it will be creating some problems. So let it be there. And this is another one resistor, and this resistor is also connected to the ground. Yesterday I said that this is the current limiting resistor. This is the current limiting resistor. So it limits the current to which is carried to the LED. But this resistor is for another one purpose. So you just note that is this resistor is known as pull down resistor. No need to know the technology behind that. You just remember there is a word, pull down resistor. It's enough. Okay. And the switch has 4 legs or 4 terminals. Of these 2 terminals will be interconnected, as well as these 2 terminals will be interconnected. They will be internally connected. So if you connect here or here, it's same. And so what we have to do is we have to take the connection diagonally. So I have given a plus 5 volt to this side, that is the right side corner of the switch, and taken the output from the left side corner of the other side, that is other side of the, from the left corner of the other side of the switch. And I have connected this to the pin number 2. Pin number 2. This is all about our circuit. That is I have connected the resistor also to the output side of the switch. So at last I will say the reason why we did that, and till that you remember it as a pull down resistor. That's all. So now we are going to simulate this circuit. And this is the circuit. I have already done this. See here, if I start the simulation, that is if I press this switch, it should blink, it should glow. When I press this switch, I am pressing this switch by using my mouse. Bring the mouse pointer here, and then just click the mouse. So if you press the switch, it should blink. So when pressing the switch, it is blinking. This is our aim. And to do this, what we have to do is we can directly connect this, as well as by directly connecting this also. By directly connecting this to the 5 volt through the ground also, we can make it blink. But we should program in such a way that is when pressing the switch, the LED should blink. That is our aim. So let us go for the coding part. Before going, so let me close this, take a new window. Circuits. Like yesterday, we should create a new circuit. First, we can take the breadboard. And next, our Arduino board. And next, the resistor. Resistor as well as our LED. LED, resistor, it should be 330 ohms. And the push button. This is the push button. Just place it here. Okay. Again, one more resistor. We need one more resistor. And the value of this resistor is 10K, 10 kilo ohms. So let us now do the connections. Ground, bend the wire. Okay. Make it black. And this is 5 volt. Okay. And make it red color. So now we have the supply here. So all these points will have 5 volt, and this will have the ground. And connect this, but that is push button switch to 5 volt. Connect to 5 volt. We should be very careful about this, and change the color to red. Here, if you touch here, you can see 2 points. It is the connection points. It is connected to plus 5 volt and the push button switch terminal. Similarly, connect this resistor to the ground. Yes, ground. And make this wire black. As well as connect this anode. to this ground. Make this also black. Okay. Then similar to yesterday, from 12, pin number 12 to the resistor, that is 330 ohm resistor. Okay. And let us give a new color. Let us define it by orange. Orange. And 2, from 2, you take a connection and give it to this push button switch. And let it give by yellow. Yellow. Okay. Our circuit is okay. So if we start the simulation now and do something else, nothing will happen. There is no reaction in this circuit. So we have to do the code. We have to code this. So our aim is, that is, this switch is connected to 5 volt in one side and 0 volt or ground at another side. So if you push this switch, this will be connected to the, that is, the 5 volt will be connected to this pin 2. If you release that switch, 0 volt will be connected to that switch, pin 2. That is the aim of using this resistor. That is, we are connecting this high resistance path to the, that is one, that is the central part of the switch. And when the switch is not pressed, the 0 volt will be connected through this resistor to the switch. When the switch is pressed, this 5 volt will be passed to the switch. So the switch will have now 2 states. Either it will have 0 or 1. So when the switch is released or not pressed, it will have a 0 at the input of the pin 2. And when the switch is pressed, there will be a 5 volt at the pin 2 of the Arduino board. So yesterday we saw about this pin 12. Yesterday we made this pin 12 as an output pin, but today we are making this pin 2 as an input pin. So to read that input only, we are using the command digital read. So let us see how to do this by using our code, that is blocks. And to remember one thing, this switch will have any one of these state, either high or low. Now we can forget about this 5 and 0 volt. If it is 5 volt, it is high, and if it is 0 volt, it is low. So the switch will have any one of these states. That is sure. Okay. So we should store that value somewhere else. We should store that value somewhere else, read that value, and based upon that value, we should make the output. So we can go for the coding part. So this is previous code. Okay. And again, we are selecting block plus text. So here, see here, there is no coding here. Void setup part as well as void loop part. And here we are going to read something else from this switch. So you just imagine you are memorizing a poem. If you are memorizing a poem, you should remember that. So what we will do is, we will by heart that or store in our mind, isn't it? Or in our brain, whatever we can say. So like that, we have to make a variable to store that. So that here we are clicking this variable and create a variable. Let us name this as button state or switch state. Yes, WITCH. Switch state. So this is the variable which we have created, and initially, that is, our aim is when we press the switch, the light should blink. So we can make this switch to 0 initially. That is, set switch state to 0. Switch state to 0. You can change this to 1 also, but it is advisable to, that is, when pressing only it should read a 1. Otherwise it should read 0. That's the case. So we have set that switch state to 0, and now we can go for a condition. When we press the switch, the light should glow. So for that, we should go to the control, and in the control we have some blocks. Of that, we should use the if else block. Bring that if else block, and now we should check our condition. What's our condition? That is, if switch state is equal to high. So if, and that is we are checking a condition. So we can that is we should use this bring this here, just place it here. It will be taken in. Just place it here, and here it is not 1. It is not 1. Instead, we should use this here, switch state. If switch state is equal to, and for this we should use the variable high. That is also available in the Max. High. So if switch state is equal to high, then what should happen? Just imagine, then the output should blink. So set which pin should be high? That is the pin number 12. That is where we have connected our LED. Should become high. So when switch is pressed, it should become high. Else, at other conditions, it should be low. So this is the program. Let us check whether our program is correct. So see here in this side, we have a new line here. Integer, int stands for integer. Switch state is equal to 0. This is known as the declaration part. That is, initially we are declaring our switch to be equal to 0. That is, it is it is generated by this code. Set switch state equal to 0. That has generated this, and this is the declaration part. And this is the setup part, initial setup. That is, we are using the pin mode to us. So we have to do one more thing. That is, we have to read the switch. So that is read digital high. Digital read input. That is, set switch state is equal to read digital. That is pin number 2. So see here, this pin mode, that is pin mode 2 is the input pin, pin mode 12 is the output pin. Now we are checking the what is the state of that switch, and now we are going to compare. That is, what is the, if the state of the switch is high, it should make the LED blink, LED glow, and if the pin, that is the pin, that is if the switch state is low, it should make the LED low or off state. So we can stop this and we can start the simulation. So see here, if I press this, it is blinking. See here. So let us explain the code once more. So initially what we did is we declared a variable. That variable name is switch state. So here this is the declaration part. Integer switch state is equal to 0. It contains three parts. This is the data type, this is the variable name, and this is the value. So data type is integer. Yes. So switch state is the variable name, and initially its value is set to 0. And next, we are reading the switch. So to read the switch, we use this input, read digital pin. That is, we are connecting it to the digital pin 2. So read digital switch state to read digital pin of pin number 2. That is, we are as per our connection, we have connected it to the pin number 2. So we made digital pin now. That is, read digital pin of 2. Then after reading that, we have to compare that. To compare that, we are using the if else statement. See here in the loop, if switch state equal to high. This is when we are writing the code here, we will be using to equal to as per our coding language. So for comparison, we are using to equal to. So before that, here there is an assignment statement. That is, switch state is equal to digital read of pin number 2. Digital read of pin number 2. All these two things are made within this first block, this pink color, this purple color block itself. That is both these things. And this is the condition which we check. And the condition checking block is inside the math block. That is the math function. See here. This is the shape. And after placing that, we remove this one and place the switch state instead. After that, we have two conditions. That is, we are comparing the switch state. Either we should make the pin number 12 high or low. So what we do is, if switch state is high, we can make it to the pin number 12 to high. Or if switch state is low, we should make this pin number 12 to low. So to make these two conditions, we went for if else condition. If we do not want to if we do not wish for this changeover, we can give single condition. Single condition is also there. In that case, we don't have an else. So if you put the else, that is the other condition will also be satisfied. This much. That's just 4 blocks. With that 4 blocks, we have created our code. And now we can copy the code. And go to our Arduino. So already I have my program. Let me delete that. Or I can make a new sketch. And it has a name. So first itself we should rename this. So let me rename this. Rename sketch as LED button. Once the rename reflects here, we can paste our code. Yes, the rename has reflected here. Delete the previous things and paste our code. And I have already connected my kit to this. So it is ready. Arduino at COM3. It may change based upon our port which we connect. So now we can verify our code. That is compiling.
Excuse me, the screen is not visible.
Is it visible now?
Yes, yes, yes.
So I have compiled this and downloading it. Uploading LED button says succeeded. That is, the program has been succeeded. So I will show you. Here. So there's a problem. Actually, my button is not working. So let me load that previous, that is, I haven't recorded my video. The difficulty is that the switch will have these 4 legs. All these 4 legs will not be straight. So it will not find a accurate position in the breadboard. That's the problem. So see here, we have done this, there is coding, and we have simulated this. And now we can go for our PowerPoint. Yes. Already we have discussed these things. So let us see what is meant by a variable. So no need to fear about this. Just for understanding, whenever you hear these words variable name, you should remember that is we declared, and there is a switch button or switch, that is switch state. That is the variable name which we gave, and it will have three states. That is integer, that is the data type of that, and button state. Here we gave it as switch state, and I have written here as button state. It is not a problem. It is the name defined by us, and it is made to 0. Its value is 0. And this part is known as the declaration part. And if else, we used an if statement and else statement together. So it is known as if else. So if the condition in the if statement is true, that is the first condition, that is the statement immediately below it will be executed. And if it fails, then the statements below the else will be executed. See here, this is the declaration part. Button state, instead of button state we changed it to switch state. Then void setup of, it will be, that is the setup, initial setup what we wish to do. And here we are declaring the pin mode, as well as that is pin 2 is the input pin and pin 12 is the output pin. Yesterday we had only one, that is pin 12 as output. Today we have one more thing, so that is pin 2 as input. And in the loop we are reading that pin, that is in the variable name button state or switch state, and then we are comparing if that button state equal to high. There we in the block we will be using only one equal to, but when we are writing program, For comparison, we should use 2 equal to. That is the comparison operator. Okay, and then again button state is high, like this our program goes. And what we wish is we are willing to conduct the third day in that day also. So it will be in the next week. So before that you do an assignment. That is, it will be very much interesting for it. No need to do in the hardware. You just do it in the software, that is in the Tinkercad. Here I have shown 2 LEDs. Instead of that, you add one more LED, and the assignment is these 3 LEDs should blink one after the another. No space, no time interval should be in between them. I will simulate it and show you. And you send this to our mail ID along with your name, class, as well as school. And the subject of the mail should be tutorial 1. Achieves VT is our mail ID. It is available in our website also. So let us go to the tutorial part and see that is what should be your output. Yes, tutorial 1. So I will not show the code. You should insert one more LED in this. I will just show this simulation here. First, that is, see here, one LED will be in on state at a condition and no delay is in between them. Once it is switched off, other one will be switched on. And you should do with 3 LEDs and post it by Friday evening. And we will be announcing the next class on by Thursday. Okay, thank you everyone of you.